Hi, welcome to the tutorial Machine Learning Models with Python. I am Arnab Chakraborty from UpDegree, and in this video we are going to cover categorization of machine learning models. So what are the different categories that are available in machine learning models? So here we can find that we are having mainly three different categories: supervised, unsupervised, and reinforcement. Let us discuss with the supervised model category. So it is task driven and labeled, and regression and classifications will be an example for this supervised categorization of the machine learning model. So why it is called task driven and labeled? That means here we'll be having a data set, and that data set will have some feature attributes, multiple feature attributes, and one outcome attribute. The outcome attribute will have multiple classes. That means depending upon the number of class, so that number of output types will be available in the output column. So here we are having the huge data set with multiple feature attributes and one outcome attribute, and it is task driven. So from this particular data set, my model will learn, and then one task will be given to the model for the forecasting and for the prediction. So input variables x and output variable y. So in case of regression, we are supposed to form one function, that is y is equal to fx. So this particular statement, this particular expression will indicate that for a new value for x, we can predict the value for y. And this function of x will be calculated, will be decided, will be formulated from the existing data set. Algorithms learns from a training data set and iteratively make predictions which are corrected, and that is teaching. So here this machine learning algorithms will be learning from the training data set. So it will learn the actual existing pattern in the training data set, and then whenever a task will be given, whenever it will be asked to get the prediction, to form the prediction on the unseen data set or unseen data row, so the predictions will be made accordingly. And the learning stops when the performance reaches to the acceptable level. So if you find that in the most of the cases the model can predict correctly, so obviously the model has got trained properly. But if the performance is not up to the mark, is not up to the expectation level, then obviously the learning will be continued. And that is our supervised model. So let us discuss this supervised model with some examples. So we know that we are having a very classical data set, and that this particular data set is known as the Irish data set. Under this Irish data set, we usually get 150 number of rows, where 50 number of rows will be for setosa, 50 number of rows will be for versicolor, and 50 number of rows will be for virginica. So Irish is one category of flower. Under this particular Irish category, we are going to have three different types of flowers. There is a versicolor, setosa, and virginica. These versicolor, setosa, and virginica, as they all of them are belonging to the Irish category, so they are having very small differences in their sepal length, sepal width, petal length, petal width. But here we are having 50 observations for each one of these three categories, and that's why the respective data set will have 150 number of rows, and it is a very classical data set and well known to all. So now here you can find that here we are having the feature attribute like sepal length, sepal width, petal length, and petal width. So these are the feature attributes, and species will be the respective outcome attribute. So here in this particular outcome attribute, we are having three classes. That means three types of outputs are possible here. So setosa, versicolor, and virginica. So this is one example of supervised learning. So my machine learning model will get it trained from this particular data pattern. So whenever a new set of sepal length, sepal width, petal length, petal width will be given to the model can predict what is the category of the flower in the Irish category. So that is the forecasting my model is supposed to make. So that is another classical example of this muffin and cupcake. So here you can see that this is our cupcake and this is our muffins. So now muffins and cupcakes are having very similar and very close the recipe. The most obvious visual difference between cupcakes and the muffins is of course the frosting, and the cupcakes are topped with creamy delicious frosting. Instead, muffins may have a sugared and top or a very thin glaze, and usually the fillings inside the muffins add enough excitement to the baked good, so there might not be anything on the top also. So that is the basic difference between the muffins and the cupcake. So cupcake is nothing but one smaller version of the cake actually. So now you see here in this particular these two different items, that is the muffins and cupcakes, we're having the set of recipes that there. So this recipe is requiring multiple ingredients. So like our flour, milk, sugar, butter, egg, baking powder, vanilla and the salt. And the respective proportions are depending whether we are going to prepare muffins or cupcake. So here you can find that 1, 2, 3, 4, 5, 6, 7, 8. So 8 feature attributes are there and 1 outcome attribute is there. This outcome attribute is having two classes, the muffin and the cupcake. So two classes are there. So now what will happen, my model will get trained itself from this particular recipe, and whenever a new recipe will be given to this particular model, the model must be capable enough to predict what kind of product it is going to prepare using that particular recipe. So whether it is a cupcake or whether it is a muffins. So in this way we can get this idea that this is our supervised learning in this case. Now let us go for unsupervised learning. So we discussed in the supervised learning that here in the data set we will be having our feature attributes and we will be having our outcome attribute. That means the output is labeled and it is a task driven. A new record set will be given to that, and then from the record set, from the feature attribute values, it will predict the outcome accordingly. But in case of unsupervised learning, it is data driven and unlabeled. That means here we don't have any kind of output column there. So no correct answers, no teacher, no labeling. So there is no labeling, there is no teacher, and there is no correct answer possible there. An algorithm looks for patterns in the data. In case of unsupervised learning models, the pattern will be recognized in our data set. Let us go for one example for the better clarification on it. So here you can find that one data set we are having. Here all the column heads are the feature attributes. There is the coffee or tree, sauces, we are having the confectionery, puddings and desserts, frozens, razors, blades and spices, and then jam and jelly, cold drinks, detergent, tissues and toilet cleaner. So all these respective items are there, the grocery items are there, and here this 1 and 0 is indicating that in a single invoice, in a single bill, which items have occurred. So 1 does not denote that one piece of that particular material has been purchased. It is not like that. It is denoting that 1 means this coffee and tea has occurred in the respective invoice in the first case. In the second case, the coffee and tea has not been purchased. So now in this particular data set, it has got filled up with zeros and ones, which will indicate that in which invoice which items have occurred and which items have not occurred. So now this is our data set for unsupervised learning, because there is no outcome column here. So what is happening from this particular set of data, we are going to predict that what is the most commonly occurring pair of those items which will be occurring very frequently in our invoices. That means we are trying to find out the frequently occurring items in our invoices. So that can be guessed, that can be calculated, that can be found out using this machine learning model, which is the unsupervised learning models. So here we are having no task, here nothing is labeled, there is no class. That is, here we are going to find out a pattern in our data. So it is a good example of unsupervised learning. Now we are having the last one, that is the reinforcement learning. So it is the reward feedback based. An algorithm learns to react to an environment, automatically determine ideal behavior within a context. So this is very important. So let us suppose we all have played there is a Candy Crush game on our mobile phones. Okay, now see, whenever the game was first loaded, we didn't know that how to play that game. So now what happened? The game opened in the level number 1. Then we tried our level best. We're trying to get what is the logic there, what are the constraints are there, what are the hurdles are there. Then we crossed the level number 1. So now after certain number of try, when we crossed our level number 1, we got a reward. We got some points, some congratulation messages came on the screen. So we get excited and we got the reward. We were feeling good. So now we promoted to the level number 2. So now again we're trying to use our prior knowledge, the previous knowledge, to cross that less respective level and go to the level number 3. So in this way, after crossing level number 1, then 2, then 3, then 4, then say I have crossed the level number 50 in this way. So now I have got sufficient experience, I've got sufficient information, so I know that how to play with the level number 51. The game rule has got changed to some extent, so we are trying to make ourselves influenced regarding that game rules, and we're trying to cross the level number 51 in this way. So now this is a reinforcement learning. There is a reward feedback based learning. So whenever I tried my level best to ride a bicycle when I was in the class 4 or 5, in that case 4 or 5 standard, when I was trying to ride a bicycle, I can remember that at that time my father was helping me. So whenever I was trying to ride a bicycle to know that how to ride it, now in that case my father gave me some support, then gave me some reward. I had a good feedback from my father when I was doing that cycling in a good way, without any failure, without falling down from the cycle, with the good success and with the good reward and feedback. So each and every day I was getting improved, and this is known as the reinforcement learning. So now in case of reinforcement learning, we'll be having our agents. The agents will be interacting with the environment, and from the environment the agent will get the feedback, the agent will learn more, and that experience, that expertise will be applied to interact with the environment in the next levels by the agents, and that is known as the reinforcement learning. So this is my 3 different categorization of machine learning models, that is supervised, unsupervised and reinforcement. So I've discussed all these models, all these respective categorization models into more details with examples and all. So in the next video we are going to cover categorization of machine learning coordinates. Please watch them and watch them all in this particular tutorial available.